Okay, so we're back again. And look at the bottom, just a reminder, if you look at the bottom of the YouTube video, open up the description, and we have the index of this meeting and the composite index for the last 4 years, which will link you back to the videos. Then we got links to our videos, link to the Slack channel, link to Zoom or something. I don't remember all those other, but there's a bunch of fun stuff at the bottom. You can go look through that. And then it should all tie together with an index file where it should show you the little icon of the thing. And well, I was going to pull it up, but I won't do that right now. So anyway, that is there, and you can go dig back through and search for stuff and pull up our videos if you have an interest in that. So the next thing is, I was saying last week that I ordered transistors in a cute little plastic box, and they sent me this. So they're not in the plastic box; they just came in a bag. It's a really nice bag, and it's labeled, but it's not what they told me it was going to be. And then I order up these things. It's a little P-channel MOSFET switch, and I went around and around on that. I was going to build one. That's why I bought those transistors. And I went to build the thing, and I couldn't find any resistors, so that stopped me. So I just ordered a couple of these, and I'm going to have to play with these and fight with them and see what I can make them do. So that's kind of where that stuff is at. I just keep collecting parts, and I was saying I could just use a relay, and somebody says, "Oh, well, the one relay that I have, which I think is this one, the one I use this one on my Sammy robot, and I think it says this is a low active input. So you pull the pin low, and the relay turns on. But I found another one in my box that I think is also a 5-volt one. So I'm going to test them and see if one works different than the other. So, if nothing else, I can just put these on for development and say, it's just like a switch. It turns the thing on and off. And then later I can I want to test this one because this one, the way the resistors they put on, it looks like it should not run at high speed, but I just want it's either on or it's off. So I figured it would work for what I'm trying to do. But everybody else was saying, oh, they were great. But again, I'm looking through the comments that might have been for something else. And somebody says, somewhere it listed one of these as being 1K hertz PWM, and 1K hertz is quite low. And that might even be the one with the different resistors that would run faster. So I just need to experiment on that stuff and see what I can make this stuff do. Other than that, I found a motor. I was going to test that RC servo thing, and I found the motor, but I haven't hooked that one up yet either. So I think that's basically all I'm doing at the moment is but still just collecting parts and looking for parts. So I got nothing else to report, I guess, this week. So I'll turn it over to somebody else. We'll put it that way.
Al.
Okay, on my end, just get sharing going. A couple of posts out there on Slack. I was messing around with the level of precision on my GGA sentences on my GPS. You might recall.
Feel free to zoom in on any of this stuff because this is almost unreadable on the recordings if you don't zoom in. So you can zoom in like one notch on that. That's probably readable now for anybody watching the recording.
So this is I've got a process where my base RTK base logs its position every day, and Jeff was asking me the last time whether this was high, something about precision, and I got to looking at this and I'm like, those zeros are probably not a good thing. So anyway, although the position is generally in the right area, and I just, it might be off 1 meter, 2 meters if you look on the Google map, but I just assumed that was just the Google map error. Bottom line is, I spent a while this week messing around with getting the precision turned up, and you can do that through uCenter. I also fought through the process of getting that to be I've got some code out there to set my GPS up using Python instead of uCenter because my GPS is now in a box, in a shed, in the yard. And I was challenging myself to be able to program it without going and pulling it out of the shed and the box in the yard. Ultimately, I had to pull it out to do some testing, but anyway, I have confirmed that this works, and we'll be watching this. We'll check this position out in 24 hours or so and see how this compares to the old one.
I also noticed you had a few days there where it didn't record. Was that intentional? It went from the 14th to the 18th.
Yeah, that was me um, rejiggering the process. So I'm a slow programmer, so it took me a while to get that rejiggered. I was down effectively for those 4 days, from getting RTK fix.
Okay. So
But
you out on your base station, do you have like a Raspberry Pi out there? What do you have or do you have no computer that it's talking to?
yeah, it's there is a Raspberry Pi, and there is, let's see, I'm trying to get to, yeah, so I got a solar panel powering a battery, powering a Pi, powering the GPS, and
Okay, yes was the answer I was looking for that you have one. My point was you might want to experiment with putting wine on that Raspberry Pi and then running uCenter remotely, or there's probably some clever ways where you can just redirect your serial port and then be able to talk to that over the network. So theoretically, you might be able to run uCenter on your base station and then have it go through these, some way to redirect your serial port to get out to your serial port on your Raspberry Pi and then talk to your board that way. So there might be other options too besides what you're doing. But if you're talking to a direct, so if you're talking to it directly from Python right now, that means you can talk to it from either your base station or from your base state or the base station or your laptop or whatever. So I guess that I guess that solves most of your problems there.
yeah, I mean, I've never fought through learning wine. I mean, I've always heard about it, but I've never tried to actually make that work. That definitely would be another option.
Well, that's just something to think about if you run into these cases where you want to change something.
The only other thing to mention is I I bought a few of these. I think 5 of them came in a package, and was trying to figure out how to actually test it. And it's interesting. I haven't really found anybody who's got a single controller to manage all 3 of the LEDs on that. So anyway, I'm just putzing around with that at the moment, and
You have a link to the actual ones that you bought on that.
I don't. I can put it in there. It's what comes up with Amazon because it came through Amazon.
Well, a lot of times these things they'll look alike, but there'll be something different. So you might be, attacking it one way, and then they might actually be a different kind of part. Is one thought I had when you're trying to do that. Now, if this looks like what I think it is, it looks like that's just 3 separate LEDs stuck inside of this thing. You have access to each one separately, and that's good if you have access to each one separately. Mine's like a common anode and common cathode or something, and I could not put all of mine in parallel. And so I didn't have that option. I later I thought if I would have got something like this where you got access to all 3 LEDs, then you got the choice of putting them in series or putting them in parallel. So that's good that you got this type of thing. And then somewhere if you look down the line, it does say they're telling you the voltages. So first of all, you can just treat those like regular LEDs right at the moment. Just lay it on the table and just pretend it's a regular LED and use a resistor and a 5-volt supply. And you should be able to get any one of those LEDs to light up. It won't be very bright off 5 volts and whatever, but they should act like regular LEDs, because if we look at the voltage over on the description, it says the red is 2 to 2.4 and the green is 2.8 to 3.2 and the blue is 2.8 to 3.2. So those are just basically, they just look like regular LEDs from from whatever standpoint. So the first thing is say, well, if there was normal LEDs, how would you drive them? So you could do the same thing to experiment here, and then and then move into the higher power. And the easiest way to do a higher power, just use a higher voltage and a low value resistor to get them to go. And then I noticed that some of that stuff you're pointing at, they were talking about some kind of driver boards and stuff, and I don't know. So anyway, I just wanted to point that out that yeah, you can just treat these like regular LEDs. Now, if you get the big 10-watt LEDs, they put like three LEDs in series inside the chip. Then you have to run it on 10 volts to get anything to light up, or you have to run it on like 9 volts is the minimum to get them to light up. But since these are all individual, they should act like regular LEDs. So then maybe we'll go back to your story. You can tell us what you did and why you don't think they're doing what they're supposed to.
I haven't hooked power up to these yet, so I'm not exactly sure how they behave. I was a little bit reticent to just start jamming voltage in it, but I think now that I'll do that. I noticed that this has got a plus sign there on that one little pad, so that must be the um, positive side, I guess.
I'm
and
guessing
they
if you
do match. That picture does match what's physically I bought. So
okay. And if you go down those pictures on the left, do they tell you where because it looks like it has red and uh,
does that tell you anything?
well, they don't tell me what I want to know, but can you scroll it down just a little bit? Is there more pictures bottom down there? No. Okay. So on the board they've stamped, what is it? Red R plus, R minus, and G
B
plus,
plus and
B plus, B minus. So the
yeah,
one on the left and the right is probably your green, and they just didn't have room to put the stuff on. So the one on the left and one on the right will be your plus G and minus G. But I figured they'd have a picture that would tell you that. If you look at is there any other pictures there that they tell you that? And you could just take your ohm meter and stick on there, and usually an ohm meter will light up an LED. So just you can go through and do your say R plus and R minus and see if your red one lights up a little bit, and then look at the reading on the meter. And then you might actually have to put it in diode setting on your voltmeter, but you should be able to get them. You can probably get them to light up that way, and if nothing else, you should be able to tell because you want to get the polarity correct on your green ones. Don't hook that up backwards because sometimes they say, oh, reverse voltage is this, and you might burn them out if you do that. So that's just it's more tips on how to identify this stuff. And it's just embarrassing. That's another thing. That's a fundamental thing you have to know. But on Amazon, they're not going to tell you that because these people don't know what they're doing when they post this crap. And maybe if we follow that, no. I was going to say, if we look at the picture of the chip, and then on the left there, they're saying, they show you the little picture of the chip, and it says red, green, blue, red, green, blue. And I thought, well, maybe we're in the corner. See, well, actually, clear over on the left there where it shows or that'd be the upper left. Go back to where you just were. Now zoom in on right there. So they're showing you the picture of the chip, and I thought, well, maybe see it also has a plus stamped on the the physical chip itself. Before they did anything, it had that on there, and they're saying it's a blue plus. That's probably just like a pin 1 indicator, is why they stuck that on there. And I was thinking, well, maybe that would be green plus, but no, it's not. So the other thing you could do is you could take an ohm meter and check the say the G plus pin right on the chip here, sit right there where you're at, and then to compare that to either the left or the right pad on the board. And it's probably going to be, yeah, just from the physical layout, so the pad on the left is going to be G plus, green plus, because it's right next to the green plus pin. And the one on the right on the heat sink is going to be, that's going to be your G minus pin. So that, I guess that tells you right there. If you just sit and look at this stuff long enough, this stuff should make sense. But then you can, as I say, take an ohm meter and stick on there, and you might be able to get them to light up a little bit by either just measuring ohms or putting in what do you call it, LED mode. They have or diode mode on most meters. I just look to see if I have a meter handy here. But if you look at the things, one of them is called diode mode, and that actually puts out enough of a voltage. And You typically put that on an LED, you'll see the LED light up just a little bit. So I think these would probably do that too.
Hmm.
So that'll give you a way to, identify before you start putting power on this stuff. And then the second point was, yeah, they look like you can treat them just like a regular LED for, just to get them going. Just use a resistor and a 5-volt power supply, and you should be able to get each one to light up individually. And then, but they won't be very bright. But then you can just move on to, either a higher voltage or lower value resistor to put more current through them. Do they list the current here? Is that what that chart on the left is? So forward voltage.
Test condition, you see there 350 milliamps.
Yeah, so that's probably saying, that they're probably saying that's the in fact, at the top under there it says continuous forward current 350 milliamp, or it says peak is 500 milliamps. So they're saying definitely don't go more than that. But I think they're saying you could comfortably run that at 350 milliamps, but you just keep track of the heat. And that one video you were showing what they were talking about measuring the heat on the thing.
Right.
And mine, I'm only running mine at like, I don't know, 50 to 100 milliamps right now, and they're pretty bright. And I found, and when I found my box of resistors, I've got some I could go back and experiment with that and crank the power way up on mine. So I could put in 12 volts at a low enough resistance to give me around 200 milliamps or so, and they're gonna be way too bright at that point, I think. So, but that's just something else I could experiment with if I get up the ambition on that.
So are you with the right resistor? Can I put 12 volts into these?
Yeah, because you just have to have greater than whatever the turn on voltage is, and then you have to have a resistor to limit the current. So you could, technically you could put 50 volts in if you had the right resistor. It's just that the more voltage you put in, the hotter your resistors are going to get
Yeah.
too. So, but yeah, you should just be able to run. And in fact, on mine, what I did, I took one of the little PWM boards like Bob has. So I've got that connected to an I2C port to my microcontroller. So I can go out and say, set channel 1 to this percentage of PWM. And then coming out of there, I've got one of those little, I think you call it a 400 watt MOSFET driver board you can buy on Amazon. And I didn't anything quite that elaborate, but that was just a convenient way to convert the logic level into the high current level. So coming out of that, I've got my battery is going into that MOSFET switch, and I've got a resistor. I think it was like 200 ohms, or I can't remember what it was. It's a lot larger value than I need, and that's why my current is so low. And then that goes right to the LED. So that way, not only can I control each one individually. So I've got 4 channels that are set up because I've got an RGB LED and then I've got an orange LED. And technically, I got 4 of each of those just because I've got one on each side. But that way I can go out to my 4 channels and set each one at whatever brightness level I want. So just in your code, you decide, do I want just red or just green or just orange, or do I want to mix my RGB? And you can do that. You can either, run the values up and down. So whatever you want, that works out. Or if you just have whatever controller you're using, if it's got multiple PWM output pins, you could do that too. If you just want them on and off, you just run logic into some kind of a high current switch, whether it be a MOSFET or a transistor or whatever. So you could just turn them on or turn them off. But if you run a PWM, then you can adjust the brightness up and down on the things. And keep in mind the resistor sets your maximum current and set that, which will be your maximum brightness. If you have PWM, you can run it all the way down to 0 if you want. So that, just pick a value and say, say 200 milliamps or 100 milliamps or whatever, just calculate that out, whatever your battery voltage is, and you want 100 milliamps, and it'll tell you what value resistor to put on there. But now that you're playing with bigger power, keep in mind when you figure out I need a 50 ohm resistor, then go calculate the power on that resistor. Say, do I need a half watt or a 1 watt or a 2 watt resistor? Because your resistors will get hot then if you start doing that kind of stuff.
And the board that Bob has you're referencing is the one that he uses to control PWM signals.
Yeah, he's running RC servos, and he's running his Sabertooth. I it's called a Sabertooth board as opposed to what he was calling it before. I forgot what it was, but yeah, it's that same board. And if you buy them from Adafruit, they're like $15, and if you buy them from Amazon, they're like $2 or $3 a piece.
Yeah.
So that just keep that in mind too. So the question is, do you have an I2C channel you can hook that up to on whatever you're driving it from? And keep in mind, I2C, you can put multiple devices on the bus too, so that you've got a pretty good chance you could connect it in parallel with anything you've got now that's already I2C. Or if you don't have any I2C, just use go to the pins on the chip and hook it up, and you'll be able to talk to it.
Yeah, it might be nice to drive it from the RPi instead of the Teensy. Simply because I mean, the goal was to get something blinking to say when it's in auto mode.
Yeah.
But
And another tip on that little board that Bob has, they already went to the trouble to put a resistor in series with each output, so you can technically put an LED right across that PWM pin and ground, and it will drive it, and it's got that limiting resistor already in there. Now, again, for your big LEDs, that's not enough current to light them up brightly, but that, again, just for quick testing, that might be a yeah, it's just a fun thing you can do. It's just hook an LED right to those pins. And if you go to Adafruit and look down their whole description, and they'll probably tell you that somewhere. They'll show you a schematic of the board and the fact that it does have, coming off that driver chip, that is like a I2C to PWM chip. Coming off that, they've got a resistor between that and the output pin. And they say, yes, you can just hook a LED directly to that if you want to.
that's all I had. Thanks for the input. That's I think I'll head down that path to get a board like you were mentioning that Bob has.
And in the meantime, just use whatever a battery and resistor to light up your LEDs. And just warn you, start playing with high power LEDs, they can get real damn bright. So be careful. You're not, don't lay it on the table, turn on, and bam, oh, I'm blinded. So, because that'll take you like 5 minutes to recover after, or something like that. And those big 10-watt LEDs, those are really bad. So don't just hook those up and not expect them to be too damn bright. So
That's a good safety tip.
well, one thing you do, just lay a piece of paper over the top of them, so it's going to at least diffuse it and block a lot of that light. Because if you're sitting there for a while, you realize, oh, I shouldn't have been watching those LEDs the last half hour, because now you are on the verge of going blind at that point. So that's just one more thing to keep in mind.
Over to you, Bob.
Okay, I'll start sharing like we did before the meeting. Screen, start broadcast, goal. And
Now just go to your menu.
okay. Up. Okay, then start off with pictures.
We see your main menu. We see your picture.
Okay, I'll start off with the Jeep. Dug it out of storage. It was covered with dirt and everything else. I'm finished cleaning this. Remove the roll bar because my other robot will go on top of that. I think the next thing to do is, in order to get ready to mount this on the Jeep, I have to rework that terminal strip. So right now, the wiring goes to the small robot, and I want to put in a Molex connector so I can switch between the big one and the little one, little robot. The other thing I want to do is, I've been running on battery and for development, and I want to be able to switch over to wall warts or AC power so I don't run the battery. Before the meeting, Al suggested, I think he uses a battery charger, and I may have a battery tender someplace that it could do that instead. That would eliminate this AC thing. Let's see. Oh, one of the problems I'm having is every time I switch between battery power and AC power, I have to disconnect the terminals. And of course, that's when everything starts falling apart. So I want to be able to come up with a solution that I don't have to do that. I just throw a switch. and go between one or the other. And I think that switch was, yeah, here it is. And I want visual confirmation of which power supply I'm on, either AC or DC. And now this light, when you press it one way, it lights up. When you press it the other way, it lights up. And of course, in the middle, nothing comes on. So now I got a visual indication of where I'm at. The other thing, and I don't know whether it's good design or not, is if I have a negative on my wall coming off from my AC charger, should I hook that up with a battery negative, or should I keep the two circuits separate? And I don't know if it's safe enough or what.
Say that again.
If I have a wall warts or AC power supply that provides 12 volts, will the ground on that AC supplied be compatible if I hook that with the negative terminal on the battery? So all I'm doing is switching the positive voltage.
Yeah, that should work. Just go ahead and connect those grounds together.
Okay, that'll reduce the number of switches I need, or complexity of the switches. Okay, that's good. And let's see what else I got. Oh, I was using a wall wart for 5-volt supply, and I couldn't use the more powerful ones because those have 3 wires in them. And of course, if you cut off the end and it's got no way of knowing what kind of voltage to put out, so you get 0. So I went back to an old power supply and cut the end off, and it was rated at 5 volts at 2.5 amps. Let's see. Oh, so I cut the end off, modified some of these, and that way I could just plug right into the circuit. But I'd have to disconnect the battery. But I found that the 5-volt voltage drops down to 4.8, and the supply will only do 2.5 amps. And while the Pi is idling, it's under an amp. But the minute I start exercising it with anything, it jumps up to 1.5 amps. And I haven't even started messing with the servos yet. So I like Al's idea better, where you got a battery tender on it, so you can switch between AC and DC. Let's see, is that it? Yeah, that's a switch. And that's about all I got, I think. Yep.
Back to your comment about Al using AC and DC. Why I don't think he's switching between AC and DC. I think it's just simply, if he wants to, he can plug in his battery charger.
Yeah, you're right.
And put it in parallel. So he's not doing any switching there. You either have it hooked up or not.
Yeah. And one last.
Jeff is right. I'm either charging my battery or depleting my battery.
So I think I'll do the same thing and forget about the other alternative.
Yeah, just
don't. The point is, you're either adding supplemental external power or not. So
yeah,
the whole thing runs the same, but if he wants to, he can hook up his battery charger and put more power back into his system while he's running. So
yeah.
I don't. There's no switching other than pulling the connector off when you're not doing anything.
Okay, I'll do that.
Just keep an eye on that battery tender. I'm a little bit nervous about mine leaving it too long.
The other thing, I was playing around with Chat GPT. I may have a screen here someplace. Oh, so I told my wife what I was doing, and she said, you're cheating. You should learn this stuff and do it yourself. Well, I'm still learning because, for example, in this case, it did generate code and everything, but I got looking at it and it's using like 4 or 5 ports on my PCA board. And it reminded me, oh, I forgot to put in the Sabertooth 2x12. So that should get me back down to just 2 ports. And I don't need a second PCA board. I can just do everything on one. So what this is teaching me is I can go ahead and outline what I want to do and then look through the code and then remember, oh, I forgot something or I want to do something different. But then I did try one script that it suggested, but it didn't work automatically. I have to put some software on the Pi first before I get into the environment. So, but it points out what you should do or not do. Let's see, what else? The other thing was, I'll go to my notes. Oh, the code 2. This is what it generates. It's assumptions, cameras, servos, the required packages, and I got an error message saying I have to import the board. Well, I've got to put it on the Pi first at the upper level. And then here's where it gave me the clue that I forgot to put the motor controller, because it's taking up an awful lot of ports and it shouldn't. And then let's see, further on down, it says I should be using Pygame, for the keyboard, but I don't know if I want to do that. And then some suggestions, double check for, and this is what I like. You can do some customization and blend them together. And they'll ask you if you want to split or you want to go. I was thinking of cheese, but then after I get familiar and I get something working, then I'll switch over to OpenCV. And that's about it. Back to Zoom. Here. Whoop. Okay. Stop share. Okay. There we go. Yeah, that's what I have. Uh-oh. There. Okay. Is that you? Oh. Okay.
Sorry, I was on mute.
Oh,
I was
me.
trying to share my screen to show you. Is this the board that you're using?
Yes, it is.
And Jeff, you're saying if I hook up 3 of these ports, I can individually control, if I've got the right resistors in there, the LED, this RGB LED with this board.
Well, sort of. Your original comment, yes, you can hook 3 LEDs up to this and control 3 separate channels to do that. And I was saying before, if you zoom in on that board, you'll see there's that row of resistors across right by the connector. So they've already got resistors in series. So you could just directly run your LED, but you're not going to get high power out of this thing. You're only going to get, that probably runs at 3.3 or 5 volts, depending on what you plug it into. So you're still going to need to put some kind of a power driver. Eventually to run your big ones, you'll have to have a power driver between this pin. So this is just going to be a logic pin, and you have to go through some kind of a translator to give you the, the higher current to run the LEDs. But to start with, yeah, you could just do that and get them to light up.
Oh, I got a question for you on if you're running servos and the motor controller can you also put in like your strip of status lights on some of the other channels and program that? Or is that too much load?
Well, I think you're mixing things. And when you say strip of LEDs, are you talking about the addressable LEDs?
Yeah.
And those have nothing to do with your PWM board. You run those directly from an IO pin off your processor.
Oh, okay.
So no, that's not an issue. Now, as far as that board, you know, I think it got 16 channels and they're all independent. It turns out that you have to run them all at the same frequency. So if you have a program to do RC servos, you can be running 60 hertz PWM, and Bob is running his Sabertooth motor driver, but it expects RC control signals. So that's why he can plug his RC servos and his giant power motor driver board all into the same thing, and they all work. And then so you've got all those extra pins there. You could just put, you know, separate LEDs on each one of those and, you know, control those separately. So you can decide you want to do that as opposed to using the addressable LED strip. So it's just more options there you can play with.
Yeah.
But just know, Bob, if you go down the path of these addressable LEDs,
Yeah.
if you want to, if I cannot see this in direct sunlight unless I'm like right on top of it.
Okay.
So
Yeah.
if you want it to operate in the daylight, especially direct sunlight, you've got to be conscious of their limitations.
Okay.
That's why I'm going with this 1 watt deal, is to try to get the brightness level to be viewable,
outside.
right outside.
Yeah, and how much were those?
Oh, I don't know.
Oh,
A couple dollars a piece, maybe.
oh, okay.
$10 for 5 or something like that.
Oh, that's not too bad. Good to know.
But I haven't figured out how to hook them up yet. Jeff seems to know, but I don't.
As I said several times, you hook them up just like a regular LED. It's just you have to decide, you know, as you want more current, you're going to have to do, you know, slightly beefier things to do that. So speaking of AI, and I'm going to have to start saying AI in quotes since AI is a meaningless term. But anyway, let me pull this up because I ran into something else. And it's a word of caution to everybody. So I was out searching for stuff and I found this page. And it came up and I wanted to know, let's see, get these out of the way. And I was searching for high side switches using P-channel MOSFETs. And here this page pops up. It's a company called Utmel. It says Utmel Electronics. They're actually like an electronics distributor, I think is what they are. And I started looking at this and I realized this looks like an AI generated page. You know, it just, again, all the typical nonsense you see. So what that means is, and there's various things like, for instance, right here, their whole premise is it says, oh, we went out to Reddit and found this, this diagram. Let me make sure I'm putting out the right stuff here. Yeah. So they said, we found this diagram on Reddit that I had already seen. The reason it caught my eye was I'd already seen this page and the guy is saying he built this and it didn't work. What's wrong with it? So this whole page is saying, oh yeah, you can hook this up. And as an example, we'll take this thing from Reddit that doesn't work and we'll tell you what's wrong with it. So basically this page just goes out to Reddit and takes all the suggestions people made and they put it down here again, as though they are suggesting this. But you just look at the whole format on this thing and it's the same concept here, where, you know, it starts off and it creates a title and here's the table of contents, and they go through all this stuff. And this is the first thing that threw me. It says this is supposed to be a schematic, and I look at the schematic and it makes no sense. They're saying that this thing apparently, see, the next to this resistor says flyback diode. Well, that's a resistor, it's not a diode. You look over here and I assume they're trying to tell you this funny looking symbol there might be the flyback diode, and that's not the way you draw a MOSFET. And it says NPN driver and shows a diode. So anyway, that is blatantly wrong. So it's gotten to the point where you can't go out and find somebody's website and trust it anymore, because it's, you know, they just threw this at it and say, oh, make up some nonsense about this. And there are some important points in this if you dig through far enough. But in general, I realize you cannot just trust anybody's website anymore because it might just be a computer with nothing to do other than scour the internet and spew nonsense. So that's another thing, you know, not only is it complaining about the people that use our stuff, but now here it's going to get to the point where everything you look at is going to be done this way, and you just won't be able to trust anything anymore. It's like going to YouTube and they keep generating stuff on YouTube that's nonsense. So you got to be you have to be more and more. You have to know more and more to know when they're doing something stupid.
So for the benefit of the NSA and anyone else listening, we're looking at www.utmel.com. You stink.
That is the and it turns out they got lots of pages here. It goes, you know, just like anything else like that, they're going to have hundreds of pages. And I didn't look, but it came up because I was searching for this P channel MOSFET. So that's what came up, and that's what I found there. So anyway, that's just something else to keep in mind, that's just the way things are going from here on out. And a lot of the stuff you watch on YouTube, you pull it up and you realize, you know, they've just taken a topic and generated a whole concept on it, made a whole video on it. And again, so you don't know whether to trust them or not. And as long as you know enough about that, forces you to learn more about it, so you know when they're just making up nonsense or blatantly lying to you. So maybe it's good that they're doing that, but I personally don't like the way things are going, but that, you know, I don't have any say other than complaining about people. So that was something else I ran across when I was looking for all this MOSFET stuff, and I realized, oh, they're doing that now, where you can't trust these people anymore. So that's all I had to complain about on that, I think.
I'm all set.
You got anything else, Bob?
No, I'm good.
Okay, then I guess I'm done too. So see you next time.
Yep.